Good morning, good afternoon, and good evening to Dr. Aisha. Today we are Group 10. Our topic choose is Student Grade Calculator. So for our group, we have Akina, Iman, me, Lin Shushu, and Khairullah. So we will straight away to the introduction. I will pass to Iman.
The student GPA calculator system helps students and academic staff efficiently calculate and manage academic performance across multiple courses. By automating GPA computations through user input of course name, credit hours, and marks, it reduces human error and simplifies the process compared to manual methods. This user-friendly tool promotes accuracy, supports the better academic decisions, and emphasizes the growing importance of digital solutions in tracking and planning educational progress. And then the objectives. The following is our goals and objective that we aim to achieve in this project. To simplify the GPA calculation process for students across multiple courses. To ensure students have the accurate and real-time feedback on their academic standing. To support better academic decision making through clear performance insights. To reduce errors caused by manual or inconsistent calculation methods, and to provide a user-friendly interface for entering and managing course data. And the problem statement. Student GPA calculator system is to offer a simple, efficient, and apparent way for students to calculate their grade point average based on their course performance, eliminating the need for manual methods or third-party tools. It supports academic institution by providing a consistent and standardized GPA evaluation process. It has transparency and reducing errors in academic reporting. The system benefits not only students but also educators and directors involved in academic planning and reviews. As a collaborative group project, the development of the student GPA calculator system also fosters teamwork, communication, and shared problem solving among its distributors. Each team member plays a vital role in system design, implementation, and testing, ensuring a comprehensive and user-friendly solution. This collaborative effort not only strengthens technical and project management skills, it also reflects the real-world dynamic of software development in academic and professional environments.
Okay, so now for methodology. Okay, for encapsulation is the concept of wrapping data, which are variables and methods that operate on the data, into a single unit, which is class. And restricting direct access to some of the object's components. For how it's used, in both course and data classes, the data members are declared as private. Only getter methods Only getter methods are provided to access them, ensuring data protection. This is to ensure data protection. As we can see in the code, that all the attributes are declared as private. So by only accessing using getter methods, can we get them to be used to other sections of the code. Okay, so now for polymorphism. Polymorphism allows object to be treated as instances of their parent or class interface. Parent, class, or interface. And the correct method is chosen at runtime. For how it's used, the student class uses the grading strategy interface at runtime. At runtime, it calls the overridden method in standard grading. As we can see in the coding, the student class uses the grading strategy interface in order to get the interface.
So in our student grade calculator system, we also applied abstraction to simplify complexity and build for flexibility. And especially we introduced the interface grading strategy, uh, which also in the student Java code, and which defines each single method for converting the marks into grade points. And this interface hides the actual implementation details of the grading logic. Instead of placing all the logic directly in the student class, we created a separate class called standard grading. Then the student class never needs to know how to grade or calculate it because it's using the interface to request a grade point. And this separation of concerns also allow us to change or add the new grading system in the future. And the abstraction here makes our code more modular, clean, easy, extendable, which is exactly what we expect in the real world enterprise level software design. And next is exception handling. Exception handling, we use it to ensure our application is stable, user friendly, and resistant to crash. So when user interact with the program by inputting the course details like credit hours and marks, this input can be prone to mistakes. For example, typing letters instead of numbers or entering more credits than usual, which is for UTM, the maximum credit is 20, the minimum is 12. So if an input is invalid, it will be detected and the program doesn't break or behave unpredictably. Instead, it displays a clear message and we prompts the user to enter valid information. So this improves both system stability and the user's trust. By handling these exceptions properly, we prevent runtime errors and we create a smoother user experience, especially for those who may not be so technical. And this reflects the kind of robustness and reliability expected in any professional grade application. I will be moving on to the demo, which will be presented by Susio.
Okay. Can you see my screen?
Can.
Okay, right now I will start my demonstration for our program and project. For example, first I'm putting OP. Credit for OP will be 4 and marks. I will just put 87 and yes. But for example, if I put more than 4, it will be repeat and the credit must be between 1 and 4. So I will put 3. If my marks I enter, for example, accidentally put another 0, then it also will do the exception handling. For example, for this only consists of 8 credit, so I put N and it will be must register at least 12 credits. I will just, if later it will detect the number, so I need to try again. For example, another course. if I put the course right now, maybe will be 19 credits. If I put one more, for example, I put 3, oh, I know, maybe one more. I forgot. Wow. Okay. For example, it will be output like this should be exceed 20 credits, so the cost will be not added. So I will just end my demo. So the output will be like this. Total 90 credits and the GPA will be 3.35. So that's all for our program for the project. So thank you very much.